Hi friends, we'll start this video with refraction. When a light beam falls on a transparent medium, some part of the light gets reflected and some part of it passes through the medium, and the direction of propagation of an obliquely incident ray of light that enters the other medium changes at the interface. See, this is the normal, this is the angle of incidence, right? This is the angle of reflection, and note that I is not equal to R. And that is what refraction is about. The light ray bends, and this phenomenon is called as refraction of light. And how does this bend? To find out, we have something called as Snell's law. Say this is medium 1 and this is medium 2. If a ray comes from medium 1 and gets refracted here into the medium 2, and you have angle of incidence here, and let this be angle of refraction. Sorry, my diagram is not so neat. However, Snell's law says that sin I by sin R, sines of angle of incidence and angle of refraction, their ratios is a constant, and that constant is known as refractive index of the second medium with respect to the first medium. If nothing is mentioned, you can take that is the refractive index with respect to the air. This is known as Snell's law. So if n is greater than 1, what does it mean? It means that sin I is greater than sin R. That means that I is greater than R. So the light ray bends towards the normal if n is greater than 1. If n is less than 1, light ray bends away from the normal. That is, angle of refraction will be greater than angle of incidence. If refractive index of medium 2 with respect to 1 is n21, then that will be equal to 1 by refractive index of medium 1 with respect to 2. Reciprocal of 1 gives the other. When you place a coin inside a glass tumbler, it appears raised to you because light ray bends right, and you perceive that the coin is raised. Actually, it is not. Look at this. Initially, you were here, and then you notice that there is a child drowning here in the water. So you want to save him. You want to go as fast as possible, right? So you should take a path which gives minimum amount of time. You should cover the distance within least amount of time. The blue line, this one will be the path which has least amount of distance but not the least amount of time, because your velocity in sand will be greater than the velocity in water, right? So what will be the time actually? It is distance covered in sand by speed in sand plus distance covered in water by speed in water. When you differentiate this with respect to time and equate it to 0, and finally you will get this one. Actually, even this obeys Snell's law. If this is the angle of incidence, say, and this is the angle of refraction, sin I by sin R is equal to velocity in sand by velocity in water. You could have given the refractive index in the previous example, that is when light passes from one medium to other, medium 1, medium 2. Even then, you could have written like this: sin I by sin R is equal to the refractive index, right? And the refractive index here is velocity of light in medium 1 by velocity of light in medium 2. This will be the refractive index of medium 2 with respect to 1. So you can express as a ratio of velocities also. And this example shows that whether it is light ray or a human, if there is something like two different velocities in two different mediums, in that case, to take the shortest time possible, you will have to take a path which obeys Snell's law, something like this one. When a light ray falls on a glass slab, say this is the angle of incidence, this will be the angle of refraction, right? Since this is a rectangular glass slab and this line is parallel to this line, this will also be R, and hence this will also be I. So I want to say that angle of incidence is equal to angle of emergence, or in another way, the emergent ray is parallel to the incident ray, and that's what I wanted to say. And this distance by which the ray gets shifted, this is the extension of incident ray. This distance is known as lateral shift. Glass has a refractive index greater than 1 with respect to air, right? So here the ray is bending towards the normal in the first case. That is because it is going from optically rarer medium to optically denser medium, and here it is going away from the normal because the light ray is going from optically denser medium to optically rarer medium. If a light ray goes from optically denser medium to a optically rarer medium, what happens? First of all, for small angle of incidence, some part of light will be reflected and some part will get refracted. And if you increase the angle of incidence, again some part of light will be refracted and some will be reflected. So as you increase the angle of incidence, the angle of refraction also increases. Observe that. So there comes one angle of incidence where the angle of refraction becomes 90. That angle of incidence is known as critical angle, or IC. And for that incidence, let us apply Snell's law. Sin IC, that is critical angle, by sin 90, that is 1, is the refractive index of medium 2 with respect to 1. This is how you calculate critical angle. And one more thing, if you increase the angle of incidence furthermore, I mean angle of incidence greater than critical angle, what happens? All the light gets reflected back and no light is transmitted. Observe that. This is known as total internal reflection. Total internal reflection, TIR, has many natural as well as technological applications. Best examples can be mirage and diamonds. The shine of diamond is because the total internal reflection. Once a light ray enters a diamond, it is supposed to undergo total internal reflection many times, and that's why it is known for its shine. And for technological application, the best example can be optical fiber, which works on the same principle. However, let's move forward. Refraction at a spherical surface. From the figure, the light ray goes and bends, right? And this is the refraction taking place at a spherical surface. Let us try to formulate this. Now, consider triangle ONM. From that, what can you say? Tan of angle NOM will be equal to NM by OM from this triangle ONM, and tan of angle NCM will be equal to MN by MC from the triangle NCM, where C is the center of that spherical surface, and tan of NIM will be equal to MN by MI from the triangle NIM, where I is the image, O is the object. Okay. Now these three are my equations. Consider this triangle ONC. For that triangle, when you extend NC, you get this one, right? So this one, angle of incidence, is the exterior angle of triangle NOC. So what can I say? That exterior angle is equal to sum of these two angles, NOM and NCM. So what is my NOM according to this equation? If NOM is very very small, I can say that tan of that angle is nothing but that angle. So this angle I can write it as NM by OM, and other angle will be NCM, that is nothing but this one, MN by MC. Again, we are taking the approximation that the rays are very very close to the principal axis, so that we want these angles to be very small. Okay, and this is my first equation. Consider this triangle NIC. For this triangle, this will be the exterior angle, NCM will be the exterior angle. So that should be equal to my angle of refraction R plus this angle NIM, right? So what can I get from that? My angle of refraction is nothing but angle NCM minus angle NIM. This is clear, and NCM can be given by MN by MC from this equation, and NIM can be given as MN by MI from this equation. Hope this is clear till now. So we got two equations for I and R, angle of incidence and angle of refraction. Let us apply Snell's law now. Snell's law says that N1 sin I, N1 is the refractive index of first medium, is equal to N2 sin R. N2 is the refractive index of second medium. Both are with respect to air, and their ratios can be given in this way also. This is Snell's law. So if I and r are very very small, I can take that sin I is nothing but I. So what did I get? N1I is N2R. Now I know what is I from the previous equation. I'll write it as Mn by Om plus Mn by Mc. That is equal to N2 of R will be Mn by Mc minus Mn by Mi. Now what happens? Mn gets cancelled in all these four terms. So OM is nothing but my object distance, that is minus u because it is towards the left, right, and Mi is plus v, that is the image distance, and MC is the radius of curvature plus r. So I'll substitute these terms in the above equation. N1 by minus u plus N1 by r. This should be equal to N2 by r minus N2 by v. The same equation can be written as N2 by v minus N1 by u is equal to N2 minus N1 by r. This is the equation which gives the relation between image distance and object distance when a light ray gets refracted at a spherical surface. Look at this problem. Radius of curvature of a spherical surface is given as plus 20 centimeters and object distance is given as u is equal to minus 100 because it is towards the left, right, and I want to find the image distance. Refractive index of second medium is given as 1.5. Since they didn't mention anything about the first medium, I am taking it to be air, so the refractive index of air is 1. Let us apply that formula. N2 by u minus N1 by N2 by v minus N1 by u is equal to N2 minus N1 by r. So what will I get? 1.5 by v, I want to find v, and 1 by minus 100, this should be equal to 0.5 by 20. This gives me the answer v as 100 centimeters. It is towards the right. Hope everything is clear till now. In the next video, we'll discuss about lens maker's formula. Keep watching. Bye.